Hey guys, Thibodeau here. Lesson 69. Nice. Comparing and ordering decimal numbers. So, we got facts, equivalent fractions, mental math, problem solving. Okay, and then our new concept. Alright. Fractions of a second are usually expressed as decimals. Okay, so if we have less than a second, we will usually say 14.6 seconds. Okay. For 28.43 seconds. It's usually how we do it, okay? Part of this is because of just the easiest way to do that, okay? Cecilia's 100-meter time was 14 and 6/10 of a second, okay? So 6/10 of a second. However, athletes often state the race times in a shorter way. She might just say 14.6 or even 14.6. She runs 100 meters in 14 seconds. She might say 14 flat. Okay. What is important to understand is that 14.6 seconds is more than 14 seconds, but less than 15 seconds. Okay. A tenth of a second is a short period of time. It is about how long it takes to blink your eyes. A hundredth of a second is even shorter. Races timed to the hundredth of a second are timed electronically rather than by a handheld stopwatch because the person with the stopwatch cannot react quickly enough to get an accurate reading. Okay, not multiple times anyway. They might be able to do it once, but it's okay. You have to be really quick. We are going to skip this. You can read through it though. Basically, just showing how difficult it is to get accurate times with the stopwatch really quickly. Okay. Compare 12.3 versus 1.23, okay? 12 points. So before you even do the decimal, all you have to do is look at the 12 versus the 1, okay? Look at the whole numbers first. If you have a whole number that's bigger than another whole number, done. You're done. You don't have to do anything else, okay? Over here, though, now here, the whole number is the same. So now, we're not looking at anything else other than 0.02, 0.20, and 0.12. Now, I put a 0 at the end of this. I did that to make it easier to see which one's bigger and which one's smaller. That 0.2, all of these could have zeros after them as much as you want. They don't do anything, okay? But you could put them there if you wanted to, okay? Just like before this one, if I wanted to, I can put a billion zeros in front of it. It doesn't change anything. Okay. 1.02. Okay. Or 1 2/100ths. See, if you say it out loud correctly, 1 2/100ths, 1 20/100ths, or 1 2/10ths, versus 1 12/100ths. Okay. It's easier to see which one's bigger and which one's smaller. Okay. The smallest number is going to be this 0.02. Another way to look at it is looking first at this number, okay? So we've crossed out this 1. Now we're comparing 0.0, 0.2, and 0.1. Well, which one's bigger? 0.2 is obviously the biggest, 0.0 is the smallest, and 0.1's in the middle. Just look at one number at a time from left to right. Okay, so these ones are all the same, so we ignore them, we move on. This one is smaller than this one and this one, so this is the smallest. This one is bigger, okay? That's all we're gonna do. That's all we have to do for this. Your written practice today, let's go ahead and do 10 through 24 even. So not a lot of work, but just a little bit. Okay. Try and do this lesson practice without me, but if you get stuck, I will have it here for you. Okay. All right. So 38.6 seconds, 37.9, 38.6 versus 37.9. Well, 38 is bigger than 37. I don't even care about the decimals. 38 is bigger. Full stop. That's it. 3.21 versus 32.1. Well, which is bigger, 3 or 32? And this isn't even a question, okay? First look before the decimal and then compare. Over here, though, 2, 2, and 2. Those are all the same. So we are now looking at, okay, 0.4, 0.04, or 0.21. Okay, so we're going to compare them, 0.4, 0.0, 0.2. Well, which one's bigger? Obviously, this is the biggest, 0.4. Okay, 0.0 has got to be the smallest, and 0.21 is the biggest. So 0.04, 0.21, 0.4. And we can put those 2's back in there. Okay. Biggest, smallest, mediumest. Okay. That's it, guys. Nice and easy. Have a good one.